So your Spring Boot app needs to save data for recall later on. Naturally, you'll want to connect to a database. But how do you do this with Spring Boot and Java? There's a few ways. One is using Spring JDBC, a lower level mechanism for connecting to and interacting with a database using SQL. Another is using Spring Data JPA, a higher level mechanism for connecting to and interacting with a database using Java objects. The sequel is generated for you. Today, we're going to cover Spring Data JPA. Okay, in this one, we're going to be using Spring JPA. We're going to stand up a Postgres database inside of Docker. We're going to load into that database 100 example records, in this case of books and authors. And then we're going to display those books and authors via our Spring Boot application on a REST API endpoint. And we're going to do this using Spring JPA. So I was thinking on the best way to demonstrate the power of Spring JPA. And I figured the best way to do that is to take an application that we built using Spring JDBC and then convert that to Spring JPA. So remembering that Spring JDBC is still connecting to a database and querying for records, but it's done at a much lower level of abstraction. Whereas Spring JPA, it's a lot easier to use. It's a lot more powerful. So what I have in front of me here is an application that we built in a previous tutorial where we did something very, very similar, but instead of using Spring JPA, we use Spring JDBC. So I figured the best way to go through this is to do an overview of the application before then converting it to Spring JPA. So before we start, I'm going to show you the model of the data that we have, and I can do that via a diagram here. So we can see we've got some books and authors. So a book has an ISBN, which is its unique identifier, and then a book has a title, and it then references an author via the author ID. We can see here that the author has an ID, of course, but then it also has a name and an age. So in this way, a book references an author, but then an author could be referenced by multiple books. So the relationship is many books have one author. It's a many-to-one relationship there. So let's go through the application. So let's start at the top with the controller. So the controller is the bit that exposes our REST API. And we can see here that it's just got a single endpoint /books, and it just returns a list of books. And it does that using the book service. So we go over to the book service here. We can see here is a single method, and that is get books. And if we take a look at the implementation, we can see that it simply just calls the book repository. So this is our service layer, and then it's calling our persistence layer, which is where our book repository lives. So if we take a look at the book repository here, it too has a single endpoint, which is just list book. But if we take a look at the implementation for this, we see something very particular to Spring JDBC. We can see here that, first of all, the book repository has an implementation. We've had to manually implement this, which is something you have to do with Spring JDBC, not with Spring JPA. And we can see here that we've got a book DAO and an author DAO. DAO standing for Data Access Object. So these DAOs match the tables almost as a one-to-one. We have a book DAO matching the book table, and then an author DAO matching the author table. We can see here that we're getting a list of books, and then we're calling the author DAO to retrieve the author information, setting it on the book before then returning the list of books in the end. Not very optimized because we're making loads of calls to the database in this way. It's probably worth taking a quick look over at the domain objects, just so we're familiar. So the domain objects that we have here is the author, the ID, the name, and the age. It's just a straightforward POJO or plain old Java object. There's nothing special on here, bar a few Lombok annotations, which just make our lives a little bit easier by generating things like getters and setters and constructors, so on and so forth. And then for the book, we can see ISBN, title, and then it references the author object. Now, again, nothing special, plain old POJO, and we're actually having to construct these manually inside of our repository implementation. So this is our implementation from the JDBC version. It works. It's not the most optimized. Let's convert this into a Spring JPA project. And where we're going to start with that is with the dependencies. So let's go down to our POM file here. Remembering this uses Maven, it would be very similar on Gradle. What we need to do is identify the artifact Spring Boot Starter JDBC. Remembering that JDBC is at a lower level than Spring JPA. Spring JPA is actually built on top of Spring JDBC. So if we were to change this from Spring Boot Starter JDBC to Spring Boot Starter Data JPA, this then adds on everything that we need on top of JDBC in order to then use JPA. Easy. We have all the dependencies that we need now. Overview here, we just have web, Lombok, PostgreSQL to connect to Postgres database, and that's pretty much it. So we can now use JPA. Where do we start? So where we start is by getting rid of the repository implementation, because we don't need to provide one of these when we're doing Spring JPA. So I'm just going to go ahead and delete this so we don't have to worry about changing anything when we do our move over to JPA. Okay, so we no longer have a repository implementation here. This is our repository interface. We don't have any implementation. Now, this is where the magic comes in. If we want Spring JPA to provide an implementation for us, basically do everything that we need to do to connect to the database, this is ultimately where we start. But in order to enable that, we actually need to tell Spring JPA a little bit more about our domain objects, a little bit more about our database, remembering that we're going to map our database using our Java objects. So let's start with the book, I think. So this is our plain old Java object, which models our book entity. However, it is just a plain old Java object. If we want to use this with Spring JPA, we have to add a little bit of extra metadata. We can do that via annotations. So we first need to add our entity. This book should be used with Spring JPA. Pretty much, this book will model a table in the database. We don't technically need this because it will figure it out by convention, but we want to say the name of the table. Now, the name of the table that we're using in our database is books. So we're saying, hey, this is a book entity, and it maps to the table books inside of the database. We then also need to say which is the unique identifier. And we happen to know that our book has an ISBN, which is a unique identifier. So we add @ID to the private string ISBN, so the instance variable here. And then we come on to author. Now, before we add the annotation for author, it's probably best that we add all of the bits and pieces to that class first. So just like before, we're going to go @entity, say, hey, this is a entity. This maps to a table @table, and the name of the table is authors. There we go. And we happen to know that this long is the ID, so let's add the ID there. Lovely stuff. So that is that class all done. But flipping back to book now, we have an author reference. So that's not a string, that's not an integer, that's not something you would typically store in a column in the database, but it's a table in its own right. And we happen to know there's a many-to-one relationship between a book and an author. So many books can have one author. So essentially what we'll do here is we'll put the annotation many-to-one. And then we also need to say how the tables join together. So we happen to know, in fact, let's go back to our diagram. So we happen to know that the author ID maps to the ID inside of the author's table here. So we need to tell Spring JPA about that. And we can do that with the annotation join column. So we'll say join column, and then we need to say the name is author ID. So we've told Spring JPA everything that it needs to know about these particular entities and how they map to the database tables. Let's go back to our repository, shall we? So back to the repository then. This is where the magic happens. I'm actually going to go ahead and comment out list books. Instead, I'm going to now make this repository extend another interface, and that is going to be CRUD repository. Now, this isn't going to solve all of our problems, but it is going to let me demonstrate a point. So first of all, CRUD repository takes some generics, so it takes some additional parameters, and it first needs to know the entity that it's dealing with, which in this case is going to be the book. It also needs to know the type of the identifier, which in this case is a string, remembering that the ISBN, the unique identifier, is a string. And with that, we get a whole bunch of different things for free. So if we then take a look at the CRUD repository, we can see that it's got things like save all. We can pass in an iterable, and we can save a whole bunch of different books in here. Find by ID, exist by ID, find all by ID. Yeah, this is pretty great. We can delete things, delete by ID. This is basically most things that you need to do in order to implement that CRUD style models that create, read, update, and delete. Now, if we go to where we're using our book repository at the moment, which is inside of our service here, there's something that we'll notice, which is the method list books is undefined because we've commented out the manual list books method that we implemented as a part of our JDBC implementation. But if I then do, we can see that we have options to find by all, with find by all returning an iterable instead of a list. The types don't match. So an iterable and a list, they both model a collection of, in this case, books, whereas a list is definitive, it's a list of books, they're all there, you can actually operate on an iterable without all of the data being available. So obviously it has some benefits when you're using it in this way, when it might take a little bit of time to get all of the records of the book from the database. That in itself is a bit of a challenge, right? Because you don't necessarily want to hit a REST API endpoint and then get 5 bajillion books back, because more often than not, that's going to crash something. If not your REST API, it's going to crash the database potentially. The typical way of dealing with this is via pagination. So you would have so many pages of different results. So page 1 might contain 10 books, page 2 another 10 books, page 3 another 10 books. You might choose that your pages are going to be a different size. Maybe, I don't know, you want 20 books a page or 25 books a page. This is a really practical way of dealing with it, and Spring makes it very, very easy for you. So what we're going to do is go back to the book repository here. And in addition to CRUD repository, because CRUD repository gives you loads of the basics, including find by ID, which is something that you almost certainly do want, we're going to extend another interface. The type it's dealing with, which is book, and then the type of the ID, which in this case is string. Okay, so we now have this paging and sorting repository, which gives us some extra bits and pieces. We have find all, and then we have this find all passing in a pageable, and then you get a page back. Page in the pageable is where the magic is. If I take a look at the pageable here, we can see that we're specifying a page of size, and then it's a page size, and then there's some extra bits and pieces in here as well, and there's also some information on how to sort. Now, what if I told you that inside of the REST API, this is an object which is available to auto-wire on every single request? That might join some dots into how we're going to use this. So what we're going to do is I'm just going to grab a reference to this to make our lives a little bit easier. Now, let's trace it back. So let's start our book repository. We know that this has some methods now, which allows us to return a page. But in order to return a page, we have to provide a pageable. So let's go up to the service level, shall we? Okay, so get books. If get books was able to provide a pageable, which is from Spring Data Domain here, then actually we can return a page. So note that we are changing the method signature here, so we are going to need to change it in the interface. We change it from list to a page, and let's just take a copy of this here. So bearing in mind, this is a red underline because it doesn't match the interface. So if we just change the interface, we don't need the final in there, and we don't need the public in there, but we do need to import page, and we do need to import pageable. Need to make sure to import the right pageable, which in this case is from Spring Data Domain. And there we go. So there is the underline gone. So we're now returning a page of books from get books, but we need this pageable. So we need to go to where we're calling our service, which in this case is in our controller. And we can see there's the red squiggle. So if we go pageable, just import that, we can pass that in to our service. And this now returns to us a page of books rather than a list. So if we then go page up here like that, because this is the type that's going to be returned, which is a response entity of a page of books. We then need to make some changes because we're no longer dealing with a list in here. And just like that, all of the red squiggles go away. So this list books method inside of the controller, so remembering that models the REST API, is going to get injected. And this pageable object is going to contain information like how many books we want to return on each page and which page we want returned. And then we're going to return a page which models that collection of books, and they're going to be displayed on the REST API. So this should be enough to return the list of books using Spring JPA instead of Spring JDBC. So what we're going to do now, let's start up our database and test it out. So we're going to do that, remembering that our database is started up using Docker. So we've got here Docker, we've got our Postgres. If you found this useful and you want to see more content just like this, then be sure to subscribe. And we have it starting up here. 5432 is the port. And then we have AddMiner, which is just a web app that sits alongside it and allows us to do things like see the tables visually, but then also import test data. So what we'll do is we'll go down to our terminal here, make sure that we're in the same directory, which we are, the same directory as our Docker Compose file. And then I'm going to type docker-compose up. And that will be enough to start up Postgres inside of Docker and then also AddMiner. So we're going to flip over to the browser now and then log into AddMiner. Okay, so this is AddMiner. We are using Postgres and not MySQL. The server is DB, remembering this DB references this here. And then our Postgres password, which is in plain text here, don't do that in production, this is a tutorial, it's okay here, is example. So we know the username happens to be Postgres, and the password in this case is example. Let's log in, and we are in, and this is our Postgres database, and there are no tables. So let's create some tables. And we can do that using our test data, which we can load in here, and then import.sql. Remembering this contains the 100 records of books and authors, and then we'll execute this, and our queries are executed and everything's okay. Perfect. And we can see here we have an authors table and a books table. And if we take a quick look and select some data, we can see here we have some ISBNs, we have a title of the book, and then the author ID. See all of the authors, data, looking good. There's all of our different authors. Our data is available. So let's start up our Spring Boot application now and see this via the REST API. Let's flip back over here. Let's make sure that our connection details are correct, which we can do by looking in the application.yaml. We can see that our driver class name is specified. We can see our URL is specified here. So PostgreSQL localhost 5432 Postgres. Then our username and password is specified as well. Remembering that you don't want to do that in production. Never want to do that in production, or even just check it into source control. You don't want it anywhere. But again, this is just a local test database with test data, so it's fine for the minute. Now, you may be thinking, hey, we use exactly the same approach when we did the Spring JDBC. What gives? Well, Spring JPA is built on Spring JDBC, so it connects in the same way. There's just that higher level of abstraction. There's all that extra stuff, all that extra value that Spring JPA provides. But it still connects in pretty much the same way. And we can start it up in pretty much the same way. So let's go a new terminal window. And then we're going to use the Maven wrapper, remembering the Maven wrapper is over here because I don't have Maven installed on my local machine. And I'm just going to use Spring Boot Run. This is a plugin which is inside of the Maven dependencies, and it just allows us to run our Spring Boot application from our command line. Okay, we're starting up, and it looks like Tomcat started on port 8080 absolutely fine. We've removed all of our Spring JDBC implementations and we're relying only on Spring JPA now. So let's go over to Postman and hit our REST API for some data. So here we are inside of Postman. We have our Git HTTP verb specified there. And then we also have our URL, localhost 8080, which is where our Spring Boot application is running. And then we're hitting /books. We have nothing in our response just yet. So let's hit send. And we have ourselves a 200 status OK. And we have ourselves, oh, look at this, a list of books. The Shadow in the Attic, Beyond the Horizon, The Last Ember, firm favourite, written by Adeline Rivers. So this is all looking good. Now, you may notice that if you did see the Spring JDBC implementation, the response is in a slightly different structure. We have this content attribute here where all of our results are returned inside of it. That's pretty interesting, right? So if I scroll down to the bottom here, you should see even more information. And this comes with the page. So we can see here that we haven't specified any sorts. We haven't specified, well, the page number is 0, the page size is 20. So there's actually only 20 records contained inside of this response. And there's some other information as well. So the beauty of this approach is we have 20 records returned, but what if we want another 20 records? Well, we just pass in this query parameter, and you get all of this for free with Spring Web when you're using it in this way with Spring JPA. So if we were to type in page equals 2 and scroll down, we can see the Dragon's Lair, the Secret Society. There are different books returned. And if we go down to our pagination, we can see here that page number is number 2. But what if we want more than 20 records returned? Well, that's another thing that we can do. Just pass in another query parameter and we'll say the size equal to 5. And we can see here 1, 2, 3, 4, 5 books returned. And then in the metadata down the bottom here, we can see that page size is 5. We're on page number 2. And it tells us there are 20 pages in total for us to paginate, flip through. And there we go. That is looking really good. We're using Spring JPA, and also we get this pagination for free via a REST API. So we are dealing with the database in a nice, efficient way. We also have the nested author information, and we're not having to do anything special with any DAOs. Spring JPA is just doing all of that for us and then optimizing the SQL usually, in order to get this back in the most efficient way. So that is how you would use Spring JPA fairly simply. But I'm going to implement another endpoint on this REST API now, just to show you how easy it is to work with this. So let's flip over to our controller once more. And this is a endpoint which returns all of our books. I just want it to return one book via its ID. So I'm going to, in a very lazy way, copy this. There we go. So, and then I'm going to type in ID. So this is basically books / and then we'll provide the ISBN of the book. In fact, ISBN is probably a better name for this parameter. And we're not going to use the pageable here because we don't actually need the pageable when we're returning a single book, because we're either going to get the book or not. Instead, we're going to use this annotation, which is path variable. And that allows us to specify this ISBN. So we're saying, look at this string, look at this field ISBN. I want you to inject that into this variable, which we're going to call ISBN. Lovely stuff. Now I'm just going to tidy this up a little bit. So we're using our book service. So this is our presentation layer, our web layer, so that sits right at the top. In our service layer, we don't really have a way of getting hold of a single book yet. So we need to implement that. We take a look at the interface. Okay, get books. That returns a page of books. Excellent. I want it to return a single book. So I'm just going to go optional book, and I'm going to call this one get book, passing in the ID of the book, which is the ISBN. And it's going to return an optional. So the optional's always returned, but it has two states. So either has something present, so a book was found and it's present, or the optional can be empty, in which case a book wasn't found, but the optional's always returned. It's a monad. So if we go to the implementation of the book service now, which is up here, we're going to ask nicely for it to implement that for us. Okay, and now we're inside of the service. We can interact with our book repository. So that's the one that extends CRUD repository and then paging and sorting repository. So I'm going to say book repository dot find by ID, passing in the ISBN. We got it for free. We just got that method completely for free, and then all of the database interaction is dealt with for us. Excellent. So we now have this available in our service. So if we go back to our controller here, we want to call get book, passing in the ISBN, which we can get from the path up here. And then we have this optional. So we need to deal with the optional because it could either be there or not. And the way that we do that is via a map. So in the case that we do have a book, we're going to return a new response entity, add the book, and we're going to do that with HTTP status, and we'll do this one as 200 OK. But in the case that we don't have this, the book wasn't returned. Let's move that down a little bit. We want to handle that case as well. So we're going to do an or else, returning a new response entity. And in this case, it's going to be a HTTP status, and we'll do not found. And then we'll return this. And we're not returning a pager book. We are simply returning a book. Or in this case, it's kind of the null equivalent. So that will still compile and run. So in summary then, we were very easily able to use a method that we got for free by by extending the CRUD repository at the persistence level. We're then able to wire that in pretty easily inside of our service level, which is pretty much just a pass-through at this point, but then gives us the opportunity to do anything extra that we want to do later. And then we're able to implement very quickly this endpoint, which returns a book or a 404 not found in an empty response in the case the book doesn't exist. So let's just test it out, shall we? Which we can do by restarting the application. Okay, our application is up and running. Everything seems okay. So let's flip back to Postman. Okay, now before I clear this, I'm just going to grab an ISBN of the Whispering Tree. And I'm going to put that into our URL here. So books / and then the ISBN. So let's hit this endpoint and see what we get. We're expecting a HTTP 200 and just that single book to be returned. What do we have? HTTP 200 status code, looking good. And The Whispering Tree by Annabelle Scott. It's been returned and everything seems fine here. That was a really easy way to implement that. Let's just check the case where we get the ISBN wrong, or there is a book that doesn't exist, I suppose. Let's just guess. What do we have here? Oh, that's a HTTP 200 status. I've guessed an ISBN for the Ghost in the Mirror. Okay, so that's not an ISBN. There's definitely not a book for that. We have a 404 not found and an empty body. So there we go. We've used Spring JPA to implement an endpoint super quickly that returns a single book, or in the case the book doesn't exist, it returns a HTTP 404. This is obviously a very basic use case and only scratches the surface for the power of JPA, but it's all of this that you get for free by extending those repositories and by using Spring JPA. So as per usual, I'll push this up to GitHub so you can access the code. And there we go. How to use Spring JPA to connect a Spring Boot application to a Postgres database. Now, if you found that useful, but you want to see it done at just a JDBC level, then be sure to check out this tutorial where we do just that. I'll see you over there.